Alright, so in today's video, we will talk about the difference between distance and displacement. And hopefully by the end, आपको ये idea बहुत ज़्यादा clear हो जाएगा. So talking about distance, we say that this is the total length covered between 2 points. And to illustrate this, I'll give a very simple example. Let's say this is point A and this is point B. तो ये आपका A जो है वो आपका घर है. And let's say at night you decide to go to some restaurant to eat food, and B is that restaurant. अब रास्ता जो है वो थोड़ा सा अजीब है. It's not a straight path, so you end up following something like this. आप अंदर अंदर जाके B में meet कर लेते हैं. So if this is, let's say, 360, well, actually I shouldn't say that. Let's say if this is 3 kilometers, so the distance between A and B is 3 kilometers, because that is the actual total length that you have covered between these 2 points. However, if I move on to displacement, displacement is basically, well, you can say it is the shortest distance between 2 points. And this will be, you will note that it will also be the straight distance. It is the shortest, but you will note it will also be the straight distance between 2 points. इसकी example अगर हम पिछले वाले भी fit करें, this is A, this is B, you take a zigzag path, alright? Now 3 kilometers is going to be the distance, but it's not the displacement, because we know कि इससे ज़्यादा एक shortest path हो सकता है, and this is not straight anyways. So the displacement then would be this right here. You can see this is a relatively straight path. It should be extremely straight. So between A and B, or let's say ये आपका 1 kilometers है. So this straight path is the shortest distance between these 2 points, and so your displacement would be 1 kilometers. Alongside, one thing that you should know is that distance is a scalar, which means the direction is not important in this case, right? So for example, if you have a distance time graph, it will never move into the negative region of the y-axis. So there's nothing known as negative distance, all right? Nothing of that sort exists. So आपने maybe 10 meters travel किए है. Let's say आपने 10 meters travel किए, उसके बाद आप 10 और कर रहे हैं, फिर आप 10 और कर रहे हैं. अब उसकी रेशो यानी कि ग्रेडियंट बदल रहा है, बट द डिस्टेंस विल ऑलवेज इंक्रीज. हो सकता है इसके बाद आपका ग्रेडियंट कम हो जाए. एक्चुअली शुड बी समथिंग लाइक दिस, या ऐसे हो जाए, यानी कि आपका डिस्टेंस कम हो रहा है विद टाइम. द पॉइंट इज दैट नन द लेस इट कैन नेवर एक्चुअली बी नेगेटिव. मतलब आपका कम तो हो सकता है, लेकिन नेगेटिव पे वापस नहीं जा सकता, एंड इट्स स्केलर. However, when we talk about displacement, displacement is a vector, which means कि इसके अंदर जो direction है वो बहुत ही ज़्यादा important है. So displacement is going to be a vector. और इसका जो graph है वो definitely negative region में जा सकता है. This is going to be positive displacement, this is going to be negative displacement. So it can be something of this sort. ठीक है, this can happen, right? Because this just means one direction, and this means के उसकी opposite direction. So I'll give you an example. For example, आप इधर से इधर A और B में जाते हैं और आप travel करते हैं तकरीबन 5 meters, right? So let's say you traveled 5 meters in one direction, and then you decide to move 2 meters back in the opposite direction. So वो फिर आपको negative region में दिखाना पड़ेगा. So our gradient is a separate thing. That's when we will cover speed and velocity, that I'll come to, but this is the entire idea between distance and displacement. Now let's look at some questions. So imagine that you are standing here at point A, and then you decide to, let's say there's a circular path, and you know it's a roundabout, and you decide to walk from path A to path B, which is basically the exact same point. And someone tells you that the circumference of this path is 1 kilometers. So my question from you is, the question then is, what is your distance and what is your displacement? Now, distance is the actual length which was covered. So that would be basically 1 kilometer, nothing different about that. But when we talk about displacement, now displacement is the shortest distance between 2 points. And so these 2 points are your starting point and your ending point. So basically, A was your starting point and B was your ending point. And so, what is the shortest distance between them? Well, basically 0 kilometers, right? Because whenever your starting point is also your ending point, the displacement will always be equal to 0. And I'll write that down over here. Whenever the starting point and ending point are the same, displacement is equal to 0. Let's look at some other questions. So let's say that you're standing at point A and a friend calls you to point B. And so this is a distance of 6 kilometers. Actually, that's huge. Let's say this is a distance of 50 centimeter. And then this is a distance of 40 centimeter. And you meet your friend, and after that, you have to come back to this point A. And so you travel these 90 centimeter back. And now, if someone is to ask you, well, what is the distance you covered from point A to point B and then back to point A, and what is your displacement, then what would be your answer? Well, if we're only talking about from point A to point B, then we're basically looking at 90 centimeter. This 90 centimeter becomes our distance as well as our displacement. Because distance is the actual length covered, which is basically 90 centimeter, and displacement is basically the shortest distance between these 2 points, which is already 90 centimeter, right? There's nothing that I can do to make it shorter than that. Now, however, if I were to talk about A to B and then B to A back, what we're looking at is positive 50 centimeter, then positive 40 centimeter, but minus 90 centimeter as well. Because remember, displacement is a vector. So if I'm taking this direction as positive, I have to take this direction as negative. And therefore, this makes the displacement as 0 centimeter mathematically as well. And even here, if you realize, if you're talking about from point A to B to back to A, your starting point and ending point are the same. And so that is why this displacement will also be equal to 0. Now, how about you have the same thing going on over here? So you go from point A to this point B to meet your friend by first covering 50 centimeter and then covering 40 centimeter. And then on your way back, you meet another friend and you basically decide to have a chit chat with her or him. And let's say you cover 40 centimeter again. Now, if someone asks you, well, how much distance did you cover between point A and B? Well, that distance will be 50 centimeter to begin with, then 40 centimeter, and then another 40 centimeter. Because remember, I should not actually be adding that. We're talking about simply the distance. And so we're going to add all of these up, the total length, which is going to become 80 plus 50, which is equal to 130. All right. Now, if someone was to ask me what is the displacement of this journey from A to C, then remember that is the shortest distance between the 2 points. So, what is the shortest distance? Here's A, here is C. So, which one is the shortest distance? Basically, this, right? And so, the displacement will be 50 centimeter. And that's it. Now, if you want to solve this mathematically, you could also do that. For example, taking this direction as positive and this direction as negative, I could say, well, he traveled plus 50, then positive 40, and then negative 40 because this is in the opposite direction. So that will also yield your answer as 50 centimeter. Well, that is going to be your displacement. Now, here's the last example. And well, there's going to be a slight variation with the next question, but this is the same scenario which we will be dealing with. So let's say again you have point A, point B, and then point C. You throw it up to a height of 10 centimeter and it falls back a height of 10 centimeter. What is the distance? Well, the distance the ball has covered is simply 20 centimeter, 10 centimeter above and then 10 centimeter down. But talking about the displacement, now, displacement, as you can see, if the person catches this ball at point C at the same height, then well, the starting point is also exactly the ending point, right? And even if you don't agree to that, you can simply apply the direction rule. So positive above, negative down. So positive 10 minus 10, and that just gives your displacement as 0 centimeter. Now, this is when the person catches the ball at the same exact height at which he threw the ball. Now, let's say if this person allows the ball to basically bounce at the floor or hit the floor, then the scenario is going to be quite different. Because if this is 10 centimeter and this right here is also 10 centimeter, but don't forget that there is going to be some height over here as well. So, talking about the distance, provided this height is 2 centimeter, the distance will be 22 centimeter. Alright. However, talking about the displacement, now remember that this and this, these are basically exact same points. But talking about this final point in A or A or C, let me label that, that will make it simpler. You can see that the shortest distance between these 2 points is simply 2 centimeter. And then again, if that does not, fulfill you much, or if it does not sound good to you, you can always apply your directions and you will get the same answer mathematically as well. So this will be 10 centimeter minus 12 centimeter, and the answer turns out to be minus 2 centimeter, where the negative dictates that it is in the downward direction. So I hope you found this video helpful. If you did, then give it a big thumbs up. In the next class, I'll tell you the difference between speed and velocity, and then that will lead us into acceleration. So till the next time, Khuda Hafiz.